Hare Krishna. Today is my 11th video. So, in the last session, in the last video, we have studied about the logarithmic differentiation. And in the logarithmic differentiation, we have studied, that is what here, the 4 type of example. What is the use of a logarithmic differentiation? And when you have to use the logarithmic differentiation? When one function is the power of another. We know the derivative of x cube. We know the derivative of a 3 raised to x, but we can't find out the derivative of a x raised to x, cos x to the power log x. Therefore, when one function is the power of another, you have to use the logarithmic differentiation, and that we have studied in the last session. Right? Now today, we have to study about the implicit function, the derivative of a implicit function. First, we have to understand what do you mean by the implicit function. To understand the implicit function, first we have to understand what do you mean by the explicit function. So what do you mean by the explicit function? Whatever the up to logarithmic differentiation, we have found it already the derivative of a explicit function, but we are not stated that is these are the explicit function, but we have already found it the derivative of a explicit function. So what do you mean by the explicit function? When the any function, suppose y, when it is entirely expressed in the form of a one variable, suppose that is equal to x square plus 2x plus 5, right? Why it is expressed entirely in the form of a x. Here why it is entirely expressed in the form of a suppose sin t plus 2 cos t plus root t. Now why it is entirely in the form of a what here t, in the variable t. When one function it is entirely expressed in one variable, that is called as the explicit function. But if the function it is like this, x square plus xy plus y square is equal to 0. Now here you can't express y it is in the form of x or x it is in the form of a y. One variable, that is you can consider x also, you can consider y also. Y you can't express in the form of x you can't express in the form of a y. Such a function, it is called as a implicit function. And today we have to find out the derivative of such a function. Suppose the function is that is log of x plus y, it is equal to cos y, isn't it? So such a function here also you can't separate, you can't express y in the form of x or x in the form of a y, isn't it? So such a function are said to be as a implicit function. And to find out, how will you find out the derivative of a implicit function? So I am going to start, that is the derivative of implicit function. Implicit function. And this is very, very important, that is the explicit function. Now I will take the simple example, x square plus xy plus y square is equal to 0. Now how will you do this? See, you have to differentiate with respect to x, right? So what is the derivative of x square? That is 2x. Here xy, again you have to apply which rule? Multiplication rule. Again x remain as it is, the derivative of a y, that is dy by dx, plus y remain as it is, the derivative of a x, that is equal to 1. Again the derivative of a y square, that is equal to 2y, and into dy by dx, because you have differentiate with respect to x. Therefore as usual you have to find out the derivative, that is the derivative of a y square, that is equal to 2y. Take the y from this and take the x from, that is ddx, and multiply with what here? Dy by dx, it is equal to 0. Right? Now see what you have to do. You have to collect the terms of dy by dx. Therefore here you have to open the bracket, that is x dy by dx plus y plus 2y dy by dx. It is equal to 0. Now what is the coefficient of a dy by dx here? X. And here what is the coefficient of a dy by dx? That is 2y. Therefore collect the terms of a dy by dx. Now what are the remaining terms here? 2x and y. Transfer these two terms to that side and that becomes the minus. You have to give the minus sign common and write 2x plus y. Because with minus both the terms get minus, isn't it? Therefore here dy by dx, it is equal to minus, this is 2x plus y divided by x plus 2. right? This is about the implicit function. I will take another example here. That is second one, x square plus y square plus twice gx plus twice fy plus c is equal to 0. Isn't it? Very simple again. Differentiate with respect to x and collect the terms of dy by dx at one side. Remaining term you have to transfer that side and find out the derivative. Again differentiate with respect to x. What is the derivative of x square? 2x. What is the derivative of y square? 2y into dy by dx. Again, when the constant it is multiplied to the function, constant remain as it is. The derivative of x that is equal to 1. Again, 2f. Constant remain as it is. The derivative of y that is dy by dx and the derivative of c that is equal to 0. 2, 2, 2, 2. Therefore, you can divide with 2 and simplify the function. Divide by 2. When you divide it with 2, x, here again y dy by dx, here again g, and here f dy by dx. Again collect the terms of dy by dx. Here the coefficient of a dy by dx y, here the coefficient of a dy by dx f into dy by dx, and this both the terms, that is x and g, you have to transfer that side, becomes minus, give the minus sign common and write x plus g. Therefore here dy by dx it is equal to minus, here x plus g divided by y plus f. Right? This is the second example of the implicit function. I will take the third one. See, suppose your question it is like this: log of x plus y it is equal to cos x y. Again how will you do this? See, here again differentiate with respect to x. Differentiate with respect to x. Again you have to apply the chain rule. Here you have to substitute u. What is the derivative of a log u? 1 by u means 1 upon x plus y. Again the derivative of a x1 and the derivative of a y, that is dy by dx. Here again you have to apply the chain rule. Here substitute u. The derivative of a cos u, that is equal to minus sin u means minus sin xy. Again apply multiplication rule. X remain as it is. The derivative of a y, that is dy by dx. Y remain as it is and the derivative of a x, that is equal to 1. Again multiply with this and open the bracket here. 1 upon x plus y. Here again 1 upon x plus y into dy by dx. Here minus x sin xy into dy by dx, and again minus plus into minus minus y sin xy. Right? Now again if you observe this, transfer this term here. Again 1 upon x plus y into dy by dx. Take the terms of a dy by dx, that is x sin xy dy by dx. Right? Now this is minus y sin xy, and this term you can transfer here, that is minus 1 upon x plus y. Right? Now you can take dy by dx common. What is remain? 1 upon x plus y plus x sin xy. Here again you can take minus sign common, and here you have got y sin xy plus 1 upon x plus y. Right? Again you can make the cross multiplication so that x plus y get cancelled. Therefore dy by dx, here in bracket make the cross multiplication, x into x plus y into sin xy divided by x plus y. Here also the same case, minus, again cross multiplication, x plus y into y into sin xy plus 1 divided by x plus y. Now here x plus y get cancelled. You have got, that is dy by dx, it is equal to, here again minus, in bracket there is a y, x plus y into sin xy plus 1 divided by, here again 1 plus x plus y sin xy. This is the result, that is dy by dx. This is the third example of what here? Implicit function, isn't it? Now there are the variety of a problems in the implicit function. So take the fourth one here, fourth, isn't it? That is ax square twice hxy plus by square, it is equal to 0. Right? Suppose the question is like this. See, suppose they have asked, that is, prove that dy by dx, it is equal to y by x. Right? Now again, see, how will you do this? Again ax square plus twice hxy plus by square, it is equal to 0. Differentiate with respect to x. A remain as it is. The derivative of x square, that is 2x. Twice h remain as it is. Here you have to apply multiplication rule. X remain as it is. The derivative of a y dy by dx. Y remain as it is. The derivative of a x, that is equal to 1. Again b remain as it is. The derivative of a y square, that is 2y into dy by dx. It is equal to 0. Again, if you observe this, the first term 2, second term 2, third term 2. Therefore, you can divide with what here? Divide by 2, isn't it? When you divide it with 2, ax plus 2 get cancelled, multiply with h to this bracket and open the bracket, hx dy by dx plus hy, right? Again, divided with 2, by dy by dx. It is equal to 0. Right? Again, collect the terms of dy by dx, hx plus by into dy by dx. These two terms you can transfer here, that is minus, here ax plus hy. Right? Therefore, dy divided by dx, it is equal to minus, this is ax plus hy divided by hx plus by. This is the result, right? First result, because they have asked to prove dy by dx is equal to y by x. Now the answer is like this, ax plus hy divided by hx plus b. Therefore, again what you have to do, you have to manage the problem. Now how will you bring ax plus hy divided by hx plus by? In place of this, we have to bring what here? The term y by x. So that term you will get itself in the problem, isn't it? Therefore, here again you have to think over and manage the problem. So how will you manage it? See here. If you observe this, ax square twice hxy plus by square, it is equal to 0, isn't it? Now this term you can write like this, ax square twice hxy you can write as a hxy plus hxy. Can you write like this? Because there is a 2 times hxy. Therefore, 2 times hxy you can write as a hxy plus hxy. Now, if you observe this, from the first 2 term you can take x common. If you take x common, what is remain? Ax plus hy. Again, from this 2 term you can take y common. What is remain? Hx plus by. It is equal to 0, right? Therefore, what do you want here? Ax plus hy divided by hx plus by. It is equal to, this term you can transfer here, minus y by x, right? Ax plus hy divided by this, it is equal to, you can write as a minus y divided by x, isn't it? Now you can put this term, put in 1. Therefore, here you have got dy by dx, it is equal to minus sign remain as it is, ax plus hy divided by hx plus by, it is equal to minus y by x, and again the minus minus plus, here you have got the result. Again, this is the very, very important example, isn't it? Mark important one, because almost they ask such a type of example. Now the interesting thing, see here, I am going to give you the bunches. See how will you get the, through that bunches, you can solve the example of the CET directly, right? So, again the bunch I am going to give you, see, what are that bunches here? The first bunch I will give, that is cos x plus y, sin x plus y is equal to 0, e raised to x plus y is equal to log of x plus y, tan x plus y, sec x plus y is equal to e raised to x plus y. Again, log of x plus y is equal to cos of x plus y, isn't it? Again, you can write as a tan x plus y is equal to e raised to x plus y. Many example you can consider like this. Here, this is the first one. If you observe this, your problem, in this problem, the first, second, third, fourth and fifth, what is given? That is the angle, whatever the angle, that is the term, that is the one parameter here, that is x plus y. In every example, the function it is expressed in the form of x plus y. Say x plus y, x plus y, x plus y. The answer is, that is dy by dx, it is equal to minus 1. For the every question, the answer is minus 1. Now let us take one simple example, that is the first example. And the remaining example, you have to do yourself, isn't it? So, the first example see here, that is cos x plus y plus sin x plus y, it is equal to 0, right? Now again, if you observe this, apply chain rule. Again, the derivative of a cos u, that is equal to minus sin u, minus sin x plus y, and the derivative of a x plus y, that is 1 plus dy by dx. Similarly, again apply chain rule. Sin u, the derivative of a sin u, that is equal to cos u, cos x plus y, and again the derivative of a u, that is x plus y, 1 plus dy by dx. It is equal to 0. So don't cancel 1 plus dy by dx. You can't cancel because the multiple of this bracket, that is sin x plus y, and the multiple of this bracket, that is cos x plus y. Therefore, what you have to do? Multiply and open the bracket, minus sin x plus y into 1, and here again minus sin x plus y into dy by dx. Right? Here again you have to multiply with cos x plus y, and again cos x plus y into dy by dx. It is equal to 0. Now see what you have to do. You have to collect the terms of dy by dx, right? So these are the two terms, that is cos x plus y minus sin x plus y. These are the coefficient of a dy by dx. Now you can write cos x plus y minus sin x plus y and into what here dy by dx. And the remaining terms you can transfer that side here. That is minus sin x plus y you can transfer. You have got sin x plus y. And here when you transfer this term, you have got minus cos x plus y. Again, if you observe this, cos x plus y minus sin x plus y remain as it is into dy by dx. But if you take minus sign common, then what you have got here, say cos x plus y minus sin x plus y. Right? So again the same bracket in this side, left hand side as well as the right hand side get cancelled, and what is remaining, dy by dx, you have got as a minus 1. So whenever your function it is in this form, that is x plus y, any example you can do here, right? That is the first I have told you, that is second, third, fourth and fifth. You can do yourself, isn't it? Try it yourself. Again I am going to give you the second bunch. See here, the second bunch, that is here again sin xy plus cos xy, it is equal to e raised to xy. Second problem here, that is first one, second one. See again tan xy plus sec xy, it is equal to 0. Third one, e raised to xy, it is equal to cos xy. Again fourth one, log xy is equal to e raised to xy. Fifth one, again sec xy it is equal to log xy. You can take any combination, right? Again, there are, how many examples are there? 5 examples. And see, sin xy plus cos xy is equal to e raised to xy. Total, all the 5 problems, it is expressed in the form of xy. So the result is here, dy by dx, it is equal to minus y by x. What is the result of this problem here? That is dy by dx, it is equal to minus y by x, right? I will take second one. See here, that is tan xy plus sec xy, it is equal to 0. Again, apply the chain rule. What is the derivative of a tan xy? Tan u. The derivative of a tan u, that is sec square u, means sec square xy. Again, apply multiplication rule. X remain as it is. The derivative of a y, that is dy by dx. Again, y remain as it is. The derivative of a x, that is equal to 1. Again, the derivative of a sec u, that is sec u into tan u. And here again, the derivative of a xy, apply multiplication rule. X remain as it is, the derivative of a y, dy by dx. Y remain as it is, the derivative of a x, that is equal to 1, and this is 0. Now see what you have to do. You have to multiply with sec square xy to this bracket, sec xy tan xy to this bracket, and open the bracket. See, this is little bit lengthy, but you have got the answer. That is what here, y by x. Here the answer of this, that is the answer, dy by dx, it is equal to minus y by x. All questions, right? So here again multiply x into, you have got as x into sec square xy into dy by dx plus y into sec square xy, sec square xy, right? Again, sec xy tan xy into x into dy by dx. Here again, sec xy tan xy into x into dy by dx, right? And here again the second term, that is y into sec xy tan xy, it is equal to 0, right? Now again collect the terms of dy by dx. Now here the coefficient of here dy by dx, that is x into sec square xy. Here again, what is the coefficient of a dy by dx? Sec xy tan xy into x, right? Therefore here x sec square xy, and here plus x sec xy into tan xy into dy by dx. See, and the both terms you can transfer that side, becomes minus here again y sec xy tan xy and minus plus y sec square xy, right? Now again, this is the left side, this is the right hand side here, isn't it? So here again, if you observe this, which two term you can take common, that is x into sec xy, you can take common. What is remain here? See, when you take x into sec xy common, here sec xy, x sec y common, what is remain? Tan xy, right? Into dy by dx, it is equal to, again from this you can take what here, y sec xy you can take common. What is remains here? That is tan xy plus sec xy, right? Now here if you observe this, the left hand side bracket and the right hand side bracket get cancelled. Sec xy plus tan xy, sec xy plus tan xy get cancelled. Again here sec xy get cancelled. What is remain? Dy by dx, it is equal to minus y by x, right? This is your second bunch. If your problem it is expressed in the form of a xy, so the result is dy by dx, it is equal to minus y by x, right? What is the first bunch here? When your problem it is in the form of a x plus y, then your result, that is dy by dx, it is equal to minus y. Again I will give the third bunch. See, with the help of these bunches you can solve easily the CET questions or JE question also, isn't it? The third bunch, see here, the third bunch. Again, cos y by x plus sin y by x, it is equal to 5, right? Now, cot y by x, it is equal to e raised to y by x, right? Now again, log of y by x, it is equal to sin y by x, right? Then comes cosec y by x, it is equal to tan y by x, right? Again, the log of y by x, it is equal to e raised to y by x. Again the 5 problem. Now see, I will take the third one, right? Or second one, any you can take here, see. Any problem. The result here is the result, see. Dy by dx, it is equal to y by x. Whenever your function, it is expressed in the form of a y by x, you have got the result, that is the dy by dx, it is equal to y by x, isn't it? So, I will take the third one, see. That is log of y by x, it is equal to sin y by x. Right. Now again, if you observe this you can write as a log of a by b means what here, log of y minus log of x, and this remain as it is, sin y by x remain as it is. Now differentiate with respect to x, see, differentiate with respect to x. The derivative of a log y, that is equal to 1 by y into dy by dx. The derivative of a log x, that is 1 by x, isn't it? Again, apply the chain rule. The derivative of a sin u, that is equal to cos u, cos of y by x, and here again you have to apply the division rule, y by x. X remain as it is. The derivative of a y, that is dy by dx, minus y remain as it is, and the derivative of a x1 divided by x square. Right. So, multiplying both side by x square y, because no term should be in the denominator. Therefore, you can complete eliminate, that is x square, and here also y. Therefore, multiplying with what here? X square y to both sides. When you multiply with x square y get cancelled. What you have got here? X square dy by dx. Right? Now, when you multiplied here, that is 1 by x into x square y. Again, 1x get cancelled. What is remain? X, and that is by xy. Right? Here again, x square get cancelled, but what is remain? Y. Therefore, you can write y cos y by x, bracket again, x dy by dx minus y. Now again, x square dy by dx minus xy. Here you can multiply with this term, that is y cos of y by x, to this bracket and open the bracket, xy cos y by x, right? Xy cos y by x dy by dx, and here again you have got y square cos y by x. Right? Now see what you have to do. Again collect the terms of dy by dx. This is one of the term, this is same. So transfer this here. That is x square minus xy cos y by x into dy by dx. See, into dy by dx. And here again you can transfer this term, that is xy minus y square cos y by x. Again, if you observe this, here from this bracket you can take x common. When you take x common, what is remain here? That is x minus y cos y by x into dy by dx. And here also you can take y common. What is remains here? X. If you take y common, what is remain? X minus y cos y by x. Again, if you observe this, say x minus y cos y by x, x minus y cos y by x. The complete bracket get cancelled from both sides, and what is remain here? Dy by dx, it is equal to y. So when your function it is in the form of a y by x, then again you have got the result, that is what your y by x. Right? So the fourth bunch here, see, fourth one. Now see, suppose the question is like this, x by y. Here also x by y. You can write x by y. Here x by y. Here x by y. Here x by y. Here also x by y. Here again x by y. Right? Again x by y. Here also x by y. Then also your result, it is dy by dx. dy by dx, it is equal to, sorry, again the same result, dy by dx, it is equal to y by x. So I am going to take the fourth one here, that is cosec x by y, it is equal to tan x by y, right? It is a little bit different. So remember, if your function it is in the form of a y by x, then the result is, that is dy by dx, it is equal to y by x, right? Now again take the fourth bunch, and I will take the problem, that is cosec x by y. If you observe this, in my teaching, I will always take the risk of the any problem, isn't it? So from that view, you have to see my video and my lectures, isn't it? So that you can understand yourself how is the teaching and which type of a problem I am going to take, isn't it? So the complete syllabus, that is should be covered through this my video, and that is my aim, isn't it? So that you should not get any problem while doing, that is the differentiation, isn't it? So I am giving here you the variety of a problem. म्हणजे एकच उद्देश आहे की व्हेरायटी ऑफ ए प्रॉब्लेम्स जर केले तुम्ही, सगळ्या त्या टाईपचे प्रॉब्लेम्स मी सॉल्व करून देऊ, यू कॅन सॉल्व द एक्सरसाइज युअरसेल्फ. स्वतःच तुम्ही ती एक्सरसाइज सॉल्व करू शकता, बिकॉज द टेक्स्टबुक प्रॉब्लेम आर व्हेरी व्हेरी इम्पॉर्टंट, बिकॉज द बोर्ड प्रिस्क्राइब to us that the state, for the state, our Maharashtra state, the board itself prescribed that book. Therefore, our duty is to cover the each and every problem in the textbook. That problems are only asked in the CET. Even the miscellaneous problem also you have to do. Most of the teachers, they eliminate, that is the miscellaneous, and they have given only. But I am taking all the miscellaneous problem in my tuition, isn't it? So every miscellaneous, every page I am taking through my tuitions, isn't it? So the here I am try to give, म्हणजे इथे मी जास्तीत जास्त तुम्हाला देण्याचा प्रयत्न करते. So take it seriously and observe the video, and you have to study yourself through my video, isn't it? Now see here, the cosec x by y, it is equal to tan x by y. So again, what is the derivative of a cosec u? That is minus cosec u into cot u, cot x by y, isn't it? And again, the derivative of a x by y. Again, y remain as it is. The derivative of a x, that is equal to 1. Minus x remain as it is. The derivative of a y, that is dy by dx, and divided by what is y square. Here also same case. The derivative of a tan u, that is equal to sec square u, means sec square x by y. And again here, apply the division rule. Y remain as it is. The derivative of a x, that is equal to 1. X remain as it is. The derivative of a y, that is dy by dx, and divided by y square. Right? Now here again, you can cut this y square, right, and multiply to this whole term, to this bracket, and open the bracket. Again minus y, cosec x by y into cot x by y, right? By when you multiply with y to this term, minus y, cosec x by y into cot x by y, minus minus plus again, here x, cosec x by y cot x by y into dy by dx, it is equal to, that is sec square x by y, that is y into sec square x by y, and here again x into sec square x by y into dy by dx. Now when you multiply with sec square x by y to both terms of this bracket, that is y into sec square x by y and minus x into sec square x by y into dy by dx. Now what you have to do? You have to collect the terms of dy by dx, right? So this is the coefficient of a dy by dx, and you can transfer this term here. Therefore x cosec x by y into cot x by y, right? You can transfer this term here, x into sec square x by y into dy by dx, right? Now this is equal to, see here, you can transfer this term to that side here. Here in this side, that is y sec square x by y, and if you transfer this term here, that is which here, y cosec x by y and into cot x by y, right? Again if you observe this here, you can take x common from this. If you take x common, cosec x by y into cot x by y plus sec square x by y, sec square x by y into dy by dx, right? Here also you can take y common. What is remains here? Sec square x by y, and here again cosec x by y into cot x by y. Any combination you can take. Again if you observe this here, cosec x by y, cot x by y, x by y plus sec square x by y, here also the same term get cancelled, and here you have got the result, that is dy by dx, it is equal to y, right? So this is the fourth bunch, right? Now I am going to take the fifth one. See, fifth one. Again see the problem. The remaining problem you can do yourself. Now again, fifth bunch. So up to 4 we have taken, that is, if your problem it is in the form x plus y, the result is minus 1. If your problem it is in the form of xy, then your result it is minus y by x. If your problem it is in the form of a y by x, then your result it is y by x. And also if your problem it is in the form of x by y, then also the result is x by y. Therefore the direct result, that is minus 1, minus y by x and y by x. So I have given the 4 bunches, and it is very useful for the CET, for the board, for JEE, any examination, because when you study the basic things, then it is useful for the any exam, any entrance exam or any theoretical exam, because the subject knowledge, whatever the chapter you are going to study, so you should know the each and everything about that problem. How many functions are there? How will you do this, isn't it? And details, you should know the details, because by doing the 1 or 2 problems, you can't study the mathematics. For the subject mathematics, you require the maximum, so maximum practice. You have to do, you have to solve the so many problems, so many variety of problems, then and only then you should get perfect in mathematics, otherwise not. Right? Now the fifth bunch here, see, again, y is equal to root of f of x plus root of f of x plus root of f of x, here dash dash dash. I have given the standard one, that is the function. Now in this function, that is f of x, you can write any function like sine root x plus sine root x. You can take any functions, right? Sine root x, this is sine root x, again sine root x, dash dash dash. Again you can take the any function, that is e raised to x, e raised to 4x plus root of e raised to 4x plus root of e raised to 4x, right? Again y is equal to, you can take tan square x or tan square 3x plus tan square 3x plus root of tan square 3x, isn't it? like this again. Here again, cos 4x plus root of cos 4x plus root of cos 4x. Now see the result is, the first one result, the direct result. What is the function? F of x. You have to find out the derivative of that, that is the derivative of f of x, that is f dash x, and 2y minus 1 is the compulsory term, isn't it? Now what is your second function here? That is sin root x. This is the first result. See what is the second result? Dy by dx. Again here f dash x means here you have to find out the derivative of a function. What is the derivative of a sin root x? That is cos root x. The derivative of a root x, that is 2 root x, and 2y minus 1 is the compulsory term, isn't it? Again if you observe this third here, that is dy by dx. What is the derivative of a e raised to 4x? The derivative of a e raised to 4x, that is e raised to 4x into 4, and the 2y minus 1 is the compulsory term, isn't it? What is the fourth one? What is the derivative of a tan square 3x? That is 2 tan 3x. The derivative of a tan 3x, that is equal to sec square 3x, and the derivative of a 3x, that is equal to 3. 3 to the 6, and divided by 2y minus 1. Therefore this is the result again, fourth one. And again the fifth one here, see, fifth result, again dy by dx, very simple. What is the derivative of a cos 4x? Minus sin 4x. The derivative of a 4x, that is equal to 4, and the 2y minus 1 is the compulsory term, isn't it? So again it is the fifth bunch, it is very, very important. If the problem it is like this, I have taken that is the only function f of x, and you can feed any function whatever you want, right? Instead of f of x, you can put sin root x, whatever you want, you can take the function by your own. स्वतःच्या मनाने तुम्ही कुठलेही फंक्शन घेऊ शकता, and the result is, first you have to find out the derivative of a function, whatever the function it is given, and in the denominator the 2y minus 1 is the compulsory term, isn't it? So how will you do this? See here, the first one, that is root of f of x plus root of f of x plus root of f of x dash dash dash. Now here what you have to do? First you have to squaring both sides, squaring both sides, both sides. Now when you make the square, only one root get eliminated. When you make the square of a square root, the root get eliminated. But there are so many roots, infinite roots are there. Root of f of x plus root of f of x plus root of f of x plus root of f of x. So many roots are there. Only first root get eliminated, and what is remain here? F of x, and the remaining terms, that is the f of x plus root of f of x plus root of f of x, because these are the infinite roots, isn't it? Therefore the same here remain, right? Only one root get eliminated by squaring this. Again f of x. Again if you observe this, that is root of f of x plus root of f of x plus root of f of x, it is nothing but what here y. Therefore instead of this you can substitute what here y. Now you can differentiate with respect to x, very simple. Again the derivative of a y square, that is 2y into dy by dx. The derivative of a f of x, that is f dash x. Again the derivative of a y, that is dy by dx. Right? Now collect the terms of dy by dx, 2y minus 1 into dy by dx. You have to transfer this term at that side. Therefore this becomes the minus. Therefore here you have got 2y minus 1 into dy by dx, and here f dash x. Therefore dy by dx, that is f dash x divided by 2y minus 1. So got it here? The result, that is f dash x divided by 2y minus 1, isn't it? Again I will take one more, that is the fourth one, isn't it? So the fourth one, see, y is equal to, that is tan square 3x plus tan square 3x root of tan square 3x plus root of tan square 3x dash dash dash, isn't it? Again squaring both sides, isn't it? Squaring both sides. Both sides. Again if you observe this, see, very simple, y square Again only the first root get eliminated, and what is remain here? Tan square 3x. Right? What is remain here? Root of tan square 3x plus root of tan square 3x plus root of tan square 3x, because there are the infinite roots, isn't it? Therefore again y square. This is tan square 3x, and here again if you observe this, this is nothing but what here? Y. Now differentiate with respect to x. Therefore the derivative of a y square, that is 2y into dy by dx. Again u square means 2u, that is 2 tan 3x. Again the derivative of a tan 3x, that is equal to sec square 3x, and the derivative of a 3x, that is 3, and here dy by dx. Again transfer here, 2y minus dy by dx, 2y minus 1 into dy by dx, and this is 2 3s are 6, isn't it? That is 6 tan 3x into sec square 3x. Therefore dy by dx, it is equal to 6 tan 3x sec square 3x divided by 2y minus 1, isn't it? So this is the sixth bunch, right? So again I will take the sixth one. This is the fifth one. Again I am going to take the sixth one. See here. So this is about the bunches, and it is very useful for the implicit function. So you can do any problem from this, isn't it? Yourself own. Try it. I will give the sixth one here. See, y is equal to again f of x to the power f of x to the power f of x dash dash dash. Again you can take any function yourself, any function. You can take any function, isn't it? Whatever you want. Now log x to the power log x to the power log x, that is again y is equal to root x root x root x. Again y is equal to tan root x tan root x tan root x, and infinite again sec square 4x sec square 4x sec square 4x dash dash dash, right? Again if you observe this, these are the 5 problems and the sixth bunch, isn't it? 5 problem of the sixth bunch. Again I will take the standard one, though the result of this, it is very long, it is little bit big, therefore we can't remember as a formula, isn't it? Therefore if you remember the method, you can do the any problem, isn't it? So whenever there is a formula, it is very long or very big, therefore don't take any risk to remember this. Therefore here only you have to remember the basic thing. How will you do this? The way you have to remember, how will you solve this problem, or how to deal with this problem, isn't it? So very simple here again, f of x to the power f of x to the power f of x to the power f of x, isn't it? Now what you have to do? Y is equal to this, the term you have to consider as a base, right? This, the first term you have to consider as a base, that is f of x. This is the base. But if you observe this here, again f of x to the power f of x to the power f of x to the power f of x, it is nothing but what here? Y. Therefore here you have to write y. Again if you observe this, f of x is the function, y is also the function, and when one function is the power of another, you have to use the logarithmic differentiation. Therefore in the logarithmic differentiation, you have to start with taking a log both sides. Log y is equal to log of f of x to the power y, isn't it? Therefore log y, it is equal to, now this y you can bring here, y into log of f of x, right? Now differentiate with respect to x. Very simple. The derivative of a log y, that is 1 by y into dy by dx. Here again apply the multiplication rule, y remain as it is. Here again apply the chain rule. The derivative of a log u, that is 1 by u, means 1 upon f of x, and the derivative of a f of x, that is f dash x. Again log of f of x remain as it is, and the derivative of a y, that is dy by dx. again collect the terms of dy by dx, right? So 1 by y, transfer this term minus log of f of x into dy by dx, right? And here again y f dash x divided by f of x, right? Now what you have to do, again multiply, cross multiply 1 minus y log f of x divided by y into dy by dx, it is equal to, that is y f dash x divided by f of x, right? So here the result is, that is dy by dx, it is equal to, now you can multiply with y, see here y into y square, here f dash x divided by f of x, and in bracket, that is 1 minus y log of f of x. Right. If you are ready to remember this formula, remember this, right? No objection. But since it is too lengthy, therefore don't remember this, no need to remember this formula, you have to remember only this method. How will you differentiate, isn't it? Once you remember this, you can do the any problem, isn't it? But if you try to remember that formula, because in the calculus so many formulas are there, म्हणून जास्त कचरा करायचा नाही लोक, right? So we have to remember some techniques, isn't it? And the formulas, it's very important. There is no choice, isn't it? So that formulas you have to remember, that is must. But such a tricks, again you have to remember for the every problem, that is objection, isn't it? Because you can't remember and you such a type of a formula and you get confused yourself. Now by using this formula, suppose you want to remember this, then here y square, it is the compulsory term, and here that is the function sec square 4x. Suppose I do this fifth problem, say what is the result here, dy by dx, again y square, it is the compulsory term, what is your function, sec square 4x, what is the derivative, that is 2 sec 4x, the derivative of is sec 4x, that is sec 4x into tan 4x into 4, isn't it, divided by, what is the function here, that is equal to sec square 4x, this is the function, again 1 minus y compulsory term and log of, what is here, that is the function sec square 4x. Again if you observe this, sec square 4x sec 4x means sec square 4x, this get cancelled, right? What is remain here, that is y square, 4 to the 8 means 8y square into tan 4x divided by 1 minus y, this 2 you can bring here also, means here you have got 2y log of sec 4x. So this is the result, isn't it? If you directly do by this formula, then you will get the result of this, what here, fifth question. So this is about the sixth bunch. So here I have finished the sixth bunch of the implicit function. Again the implicit function, it is very vast. We have to take the again 2 sessions, isn't it? I think again we require the 2 sessions about the implicit function. So again in the next session I am going to continue, that is the implicit function, right? This is the implicit function part 1, right? This is the implicit function part 1, and the next 2 session, I will take the about the implicit function, that is the next 2 part I will take in the next session. And here the good day for you, and again if you like my video, then share it and subscribe my channel.